day. But there's going to be like a small added layer of complexity, mostly involving fractions. Okay? So I'm going to say this, and I'll probably say this a lot. In just about every case, if we can avoid dealing with a fraction, we will avoid dealing with the fraction. There are going to be some times where it's just unavoidable and we have to directly attack it in its fractional form. But there are going to be plenty of times when we look at something and say, oh man, can I make that not a fraction? Oh, I can. I can make that not a fraction. So we're going to seek to do that as much as we can. Okay? So number one is a nice example of that. It's sine of x divided by cosine squared of x for that first integrand. So maybe I do this, where I split it up first, and I say I've got this minus that, and realize that these two different terms in this integrand are very different, and so we will use a different strategy for those two different terms. Would you guys agree with me that the second one, at least on the surface, appears to be much easier than the first one? Anybody know what the antiderivative of 2 to the x is? There it is. So I think right away we can say that this second term antiderivative is 1 over natural log of 2 times 2 to the x. We've got that plus c. But the first term, not so easy. We're going to do a little bit of trig manipulation. You don't have to do it this way, but at this stage, it's probably the best way. So check this out. Here's just an example. I just want to kind of lay some tracks, some groundwork with you as far as some of the things maybe you could do. Here is what I would suggest on this one. Take the numerator and leave it as is, but take the denominator and split it up into what it really is, which is cosine of x times cosine of x. We're going to use some trig identities. Anything jump into mind right now? What do you see?
Why couldn't you, instead of separating them, move the cosine up and just have it as cosine x to the negatives?
Good question. So that would get us into where your integrand is a composite, right? Because cosine squared of x is really cosine of x in parentheses squared.
Yeah.
And if we move it up, now it's cosine of x in parentheses to the negative 2. And we have to, and we will do this. We'll do this a little bit next week. We'll do it a ton in January, where we look at it and say, wow, look at the integrand is a composite and kind of a product. And we will go there. So the answer is you could do that, but it's maybe just like a tiny bit beyond where we are right now, or at least where I want to go at this point. But we'll get there. We definitely will. So was it you were going to ask the same thing about flipping up? We'll get there. We'll get there. And that's the other way, one of the other ways you could do this. So Hunter suggested he saw some trig identities, right? So I'll highlight it for you. He saw this and thought, man, that looks a lot like something I've seen before. And then he saw this and thought, that looks like something familiar as well. What's sine over cosine? And 1 over cosine? So then when you rewrite like that, maybe this becomes something that looks a lot more familiar to you because you've done so many derivatives and all that practicing. Maybe you would look at that tangent of x times secant of x and say, wait a minute, isn't that just the derivative of secant? And so wouldn't the antiderivative of that have to be secant? So that's where we would go with this one and say this is secant of x minus 1 over ln of 2 times 2 to the x. Get that plus c in there, and we're good. Mary?
Do you have to say plus 2c?
No. So it's true that if we do split out, it does seem like there's a plus c on the first term and a plus c on the second term. But if both of those constants are unknown, and I take some unknown constant and I add it to some other unknown constant, what do I get? Some unknown constant, right? And we'll just represent that with a c. Yeah. To be honest with you, if you put a 2c there, it's really not wrong. It's just 2 times some unknown constant, but it's just more customary. Just say, yeah, it's just a c. Okay. Questions, concerns? Do you see how we're using the exact same skills, but we have to like kind of get to the skill a little bit? Okay. So number 2 is a really nice example of that same thing. Can I give you like a really general rule that I think is going to be true in just about every case? Take a look at again, in number 2 we have a fraction. You all can see that. What's the degree of the numerator? Say again? Cubed. That's right. So degree of the numerator is 3. Degree of the bottom is? 1. So anytime the degree of the numerator is bigger than the degree of the denominator. So I said anytime. That's a really broad, bold statement, right? Anytime you see degree of numerator bigger than degree of denominator, your first step is almost always going to involve some kind of division. Now in 2, it's very simple division. We're going to get to one a little bit later where the division is a little more complicated. We'll use synthetic division. But this one is a very simple division. Okay? So see if you guys can simplify this. See if you guys can get this down to where it's not a fraction. Remember, if we can avoid dealing with a fraction head on, we're going to avoid it. So let's do a little division here to try to get us. And there's a variety of ways the division could look. What I'm trying to say is simplify this so that there's no more. Well, maybe there's one fraction left. You could do it. That's one way. And then just distribute. That's really division.
Wait, so it wouldn't just be like that? Just add it?
No, not added. It would be times.
Okay. Do that to everything?
Mm-hmm. So I'm going to write some examples of how this could look. You feel free just to keep working if you want. I'll show you 2 different ways this could look.
Isn't it 1/3 x cubed? Is that what you said?
Yeah.
Oh,
I said x cubed over 3.
Oh.
I'd say either of those looks. If you want to take a peek at my first steps, I haven't completed anything yet. I think either one of those is valid and could work for you. They would work fine in this scenario. Yeah, so then your next step for on the left, it would just be reduce each of your fractions, right? So here it would be x squared plus 7x minus 1 plus 1 over x dx. And then amazingly enough, if you distribute over here on the right option, don't you just automatically get the exact same thing? Zach, I'll answer your question while I'm writing. Go ahead.
How necessary is it to do the first step? Like I did the steps on the left, but I skipped the like.
Oh, totally. To me, this is just like minor algebra steps.
Okay.
So if you could get to here without showing any in between stuff, totally fine.
Okay.
Totally fine with that. In fact, I would probably do the exact same thing. I just wanted to make sure folks knew like how we were getting from point A to point B. Okay, so then I'm hoping now that once you did that simplification, you would look at either one of those, obviously they're the same now, and say, wow, look at that, it's just 1, 2, 3 power rules, right? And then the last one ends up being what? The last term. Yeah, but what's the antiderivative of that? It's natural log. Yeah, it's going to be a natural log. So to finish this one, I'll just put my final answer here in the middle. It would be 1/3 x cubed plus 7/2 x squared minus x. Now that's your 3 power rules, right? And then the last one would be plus natural log absolute value of x. And then don't forget your plus c on the end. So whichever way you went, we should end up in the red box. So questions? This is where, boy, I sure hope what I said makes sense. It made sense in my head, but if I confused you or you were expecting one thing and you got another, this is where you say, wait a minute, that last term doesn't make sense to me, or why did you do this, or why wouldn't we do that? All kinds of great questions that could be asked. Okay. So maybe you'll see number 3, we're back to 2 terms. Can you see how the first term in number 3 is really similar to what we just did? It's different form for sure. There's some different elements, but really the same concept. So why don't you try number 3 real quick? I'll give you a couple minutes and I'll quietly work through a solution up there. We can compare notes and we'll wrap it up with number 4. me know if you're wanting to talk about anything. You can always discuss with your friend, classmates. Doing okay? Isabel, you doing okay? You think so? Okay. Yeah, what's up? See? I think that's a good first step on this one, for sure. One thing I would say, Isabella, is don't forget your integral. Like you flipped up, but your tall, skinny s disappeared. Well, really, remember in math, if something disappears, you're telling me, hey, I did that thing. So that's not there. You're kind of saying, hey, I did it. Truth is, you haven't done it yet. So I would leave it in there.
Is the video from yesterday on YouTube?
It should be posted.
Okay.
Should be posted
I looked
on
on
Schoology.
Schoology, and I didn't see it there this morning. But
I sure hope so. If I forgot, let me know. If it ever seems like I forgot, definitely tell me. It should be on YouTube labeled Lake Unit 5 Day 1.
Okay.
Yeah.
Sounds good.
Okay. You guys doing okay? Any questions?
Oh, it's not a question. So here, you're subtracting, so why is it still plus C at the end?
So it's always, you could, like, I don't know why we're so, like, positive about this, but because plus a negative is the same thing as minus a positive, and plus a positive is the same thing as minus a negative, we just always write plus C. Later on, you're going to find out when you get to Unit 6, we're going to find out that there are going to be some opportunities where we can find what the C is. Sometimes the C is going to be a negative number, sometimes it's going to be a positive number. So we could put minus C, and really that's not wrong. Our custom is just we put plus C. Just because given the right positives and negatives, the C can kind of be either way, and it would just work out the same way. So we just do it the same way every time. Yep. All right, let's see how this one went for you. Here would be one way of approaching this. You could take that first term and write it separate as a separate antiderivative from the second term. And that might be wise because isn't the second term the easiest of the bunch? Right? We know the antiderivative of e to the x is just e to the x. So our second term is for sure going to be that. Then, over here on the left, we would simplify. And no matter how you simplified, you should have ended up with x to the 1/2 plus x to the negative 1/2. So I don't know what algebra you used, or maybe you just did it in your head. Doesn't really matter. You should end up with that. Is that working okay? Nobody seems like they're panicking at all, seeing confidence, yes? Okay. So then it comes down to just doing a couple of power rules there on the left. So this would end up being 2/3 x to the 3/2 plus 2 x to the 1/2. I am doing some copy dot flops in my head there, right? Dividing by 1/2 is the same as multiplying by 2. Dividing by 3/2 is the same as multiplying by 2/3. So I am kind of skipping that step real quick. Question, Luke?
Why is it not minus 2 to the 1/2?
Why is it not?
Because you would.
Oh, no, it's correct up there. So if you're doing this, when you execute the power rule for integrals, what you do is you add 1 to the old exponent, and then you divide by the new exponent. So this ends up being negative 1/2 plus 1 is positive 1/2 over positive 1/2, which is 2. Yeah. You're almost kind of like doing a derivative integral hybrid, right? Yeah. Good question. Great example of a question. I thought it was going to be this, and you wrote that, right? Thanks for asking. What else? Okay, fair enough. So then our final example then is number 4. What do you notice about number 4 that might give you some direction right away? It's a fraction, obviously, but what about the fraction? The degree, right? Yeah, he said it well. The degree on the top is 3, the degree on the bottom is 1. But did you notice that this time the denominator is not just a nice simple x, it's a binomial, right? So we can't just go through and, like there would be, I'll tell you what, there would be some terrifying algebra that could be done here. Like check this out. What if, please don't do any of this, just watch. I can see people being tempted to do this, and maybe they take this and they flip this up, and they get into a little bit of a panic, and they're like, I don't know, how about this? And they go like this, and then they start wanting to like distribute stuff in there, and they make this really awful algebra mess, right? So at its core, math should make sense. It should be logical. So if you find yourself feeling like you need to make up a rule that you think probably isn't true, let's go a different way. So the idea here is that if you are dividing by a binomial, you can't just flip up and distribute like we did with the monomial. We've got to actually do the division. You really have a couple options here, right? You could do long division. Isn't that bad, but isn't synthetic easier? It's my opinion. You might not share it. If you want to do long division, totally fine with that. Couple of pitfalls to watch out for here. The way that I usually do synthetic division, I have like a little box and then a horizontal line. What number in our case here, what would go in that little half box? It's -1, right? It's the opposite of the numerical part of the binomial. So -1 goes there. And then stretched off to the right here, there would be some numbers. What numbers would go off to the right? Good. So some of you noticed that the x squared degree was missing, so we have to fill that with a 0. Right? There was no x squared. And remember, anytime a degree is missing, you have a placeholder essentially, right? You put a 0 there. And then the way synthetic division works is you bring the first one down, and then we start our cycle. We go divisor, which is -1. We go -1 times 2, and we write the result right there. And then what do we do vertically? We add. So 0 plus -2 is -2. That's one cycle. We just do a couple more, and we're there. So -1 times -2 is 2. We add again, we get -3. Last multiplication gets me a 3. Last addition gets me an 11.
Oh my gosh.
You remembering this? Or are you having flashbacks to DC pre-calc? Both? Okay. So just remember now, didn't we divide a cubed by a first degree? So what would be the new degree? 2, yeah. So I would then take that result, my quotient there, and I would rewrite it as 2x squared minus 2x minus 3. And then what do we do with that 11? That's right, we put it over the divisor. So it'd be plus 11 over x plus 1. And now we've gone from something that was a fraction, and frankly, we couldn't really work with it at all. We didn't really have an option to handle it in its original form. This made it a much easier form. Let's hear from you guys. What do you think the antiderivative of the first term would be? 2/3 x cubed. Okay, I feel good about Hunter and the power rule. Let's see if anybody else knows about the power rule. How about the second term's antiderivative? What do you think? Minus x squared. Good. And then the -3. Minus 3x. Good. And we come up to that last term. It's a little bit strange looking. Any guesses on what this would be? What do you think?
11 ln of x plus 1.
Perfect. The absolute values, right? Yeah. So plus natural log, absolute value of x plus, oops, I lost my 11. Sorry, let me start over. Plus 11, natural log, absolute value of x plus 1, and then don't forget the plus c. And like I've said a bunch of other times, if you ever get to a moment you have some doubts and you think, whoa, that was okay, but I'm unsure of myself, can't you just do a derivative? And say, well, I know I'm really good at derivatives. Why don't I just try to do a derivative and see if I end up with my original integrand? And if you do, that means you probably did it just fine. Okay, so that's antiderivative skills 1. Feel like you need some practice on that? We'll practice for a while, for sure, before we do any quizzes or anything like that. So if y'all would, get everything packed up. We'll do your quiz right now. Your quiz, believe it or not, is calculator free. It is. I've designed this to be a really friendly quiz.
I like friendly.
As far as the numbers go, it's extremely friendly.
I like concept friendly.